Hi, this is Shabana Sultana, working as an associate professor in the Jntu Engineering College. Today, I want to discuss about the electrochemistry unit in the saturated Calomel electrode. In the last class up to the reference electrode, we have discussed standard hydrogen electrode, which is used as a first reference electrode. Today, I'm going to deal about the second reference electrode, which is known as standard Calomel electrode. In this electrode is used for measuring the single electrode potential, and it is considered as a secondary standard electrode, and it consists of the glass tube having a side tube on each side. See here, this is a construction of the Calomel electrode. So it consists of a glass tube which contains a side tube on each side. The mercury of high purity is placed at the bottom. The mercury of high purity is placed at the bottom of this tube and connected to the circuit by means of platinum wire sealed with a glass tube. The surface of the mercury is covered with a paste. This one. The surface of the mercury is covered with a paste of mercurous chloride and mercury. This is Hg2Cl2 with mercury. In KCl solution, which is the electrolyte. The electrolyte is a solution of potassium chloride. The electrode is connected with the help of a side tube. With the help of a side tube on the left, through which the salt bridge with another electrode whose potential has to be determined, or it has to be measured. The potential of the Calomel electrode depends upon the concentration of KCl solution. The electrode is represented as Hg2Cl2, which is in the solid state, with an electrolyte, that is KCl, or it is also represented as like this, Hg, comma Hg2Cl2, comma KCl. Here, it consists of a glass tube that contains mercury at the bottom, covered with a paste of HgCl2. What I told you now. After that, above this, the tube is filled with KCl solution. The platinum wire is in touch with the mercury as it is used for the electric contact. The KCl solution inside the tube can have the ionic contact with the solution outside and acts as a salt bridge. And Calomel electrode acts as an anode or cathode electrode, depending upon the nature of the other electrode. Another inlet is there at the right side of the Calomel electrode to pour the KCl solution into this. The electrode potential of the saturated Calomel electrode is about 0.2422 volts. For one normal KCl, so the standard reduction potential is 0.28 volts, whereas for 0.1 normal KCl solution, the reduction potential is 0.0 3338 ohms. The Calomel electrode is only used as a reducing electrode. We have to be remember that it is used as a reducing electrode. Coming to the working of the Calomel electrode, if the reduction occurs at the Calomel electrode, then it is represented as like this. Hg2 plus, which is in the ionic state, with 2 electrons that gives rise to 2 Hg, which is in the liquid state. Afterwards, Hg2Cl2 that gives rise to Hg2 2 plus 2 electrons, which both are in aqueous state. It results in increasing the concentration of the chloride ion in the solution, because chloride ion will be comes out from the Hg2Cl2, so that the concentration of the chloride ion, that is a KCl, will be increased in the solution. Suppose if the oxidation occurred at the Calomel electrode, then reaction may be represented as like this. Hg, which is in the liquid form, that is a pure Hg, they undergo the ionization and converted into Hg2 plus with the liberation of 2 electrons. This Hg2 plus, with the help of the chloride ion which is present in the solution, they converted into Hg2Cl2. It results in a decrease in the concentration of the chloride ion, because whatever the chloride ion which is present in the solution, it is taken up by this Hg2Cl2 and converted into the solid, that means the solid is deposited, so that the concentration of the chloride ion will be decreased in the solution and increases the Hg2Cl2 ions in the solution. Thus, in case of the Calomel electrode, the electrode reactions is represented as like this. It is a reversible reaction. Mercurous chloride, it taken the 1 electron, 2 electrons, and it is converted into the liquid mercury along with the elimination of the chloride ion, and the electrode potential is given as this one. E is equal to E0Cl bar Hg2Cl2 bar platinum, because we take the platinum wire as electrode, minus 0.0591 log Cl concentration of the Cl minus ions. I already told you that this electrode potential, the theory of electrode potential is completely based on the Leibniz equation. Thus, the potential of the Calomel electrode depends on the concentration of the KCl. I already told you that if the concentration of the KCl is 0.1 normal, then the electrode potential value is 0.334 volts at standard temperature, that is at the room temperature 25 degrees centigrade. Whereas if the KCl concentration is 1, then the electrode potential value will be 0.28 volts. Suppose if you take the KCl concentration is saturated, then the value will be, the electrode potential value will be 0.2422 volts at 25 degrees centigrade. So this is about the Calomel electrode description. Coming to the next topic, that is the concentration of the cell. What is concentration? The cell in which there is no net chemical change and the reaction. That means the overall reaction, the net reaction will be zero potential. That type of cell is known as the concentration cell. In this, whatever the electrical energy which is produced due to the transfer of electrons from the region of high concentration to the region of low concentration. This is the basic principle in the concentration cell. We have to remember 2 points in the concentration cell. One is the net chemical change in the cell is 0. That means there is no net chemical change in the cell. And the second condition is the chemical energy is produced by the transfer of electrons from the region of high concentration to the region of low concentration. That means the transfer of electrons takes place from anode to cathode. And this concentration cell is of 2 types. They are electrode concentration cell and electrolyte concentration cell. Electrode concentration cell is nothing but it is an electrochemical concentration cell. I already told you that what is electrochemical cell. It is a device which converts the chemical energy into electrical energy. Whereas the electrolyte means it is a reverse, vice versa. It is a device which converts the electrical energy into chemical energy. So coming to the first electrode concentration cell, this cell consists of 2 electrodes at different concentrations are dipped in the same electrolyte solution. In this, whatever the electrode is present, we have to take the same electrolyte, but the concentration is different. One is at different concentration and different pressure. One electrode is at the pressure P1 and another electrode is maintained at the pressure P2. The 2 hydrogen electrodes at different gas pressures is immersed in the same solution of the hydrogen ion. It constitutes the electrode concentration cell. That means here, this is the construction of electrode concentration cell. In this electrode concentration cell, this is considered as one half cell and this is considered as another half cell. In this, it consists of the platinum electrode, which is placed in the inverted glass tube, and it is having one inlet pipe to pump the hydrogen gas at the pressure P1. And in the another half cell also, it consists of the platinum wire, which is present in the inverted glass bulb, and it is having another inlet pipe at the pressure P2. And both are connected with the help of the salt bridge. And in this, HCl solution will be taken at 1 molar concentration. And this platinum wire is connected to the electric current circuit. This is about the construction. See here, 2 hydrogen electrodes at different gas pressure is taken. By passing the hydrogen gas at 1 atmospheric pressure, the gas will be liberated into the solution, where here HCl solution is there, which ionizes into H plus and Cl minus ions, and the H2 gas will be liberated out, and oxidation takes place in the left half cell, and with the liberation of electrons. And whatever the electron will be liberated, it is transferred from high potential area to the low potential area. That means from anode to cathode. The EMF of the cell is calculated by using the Nernst equation at 25 degrees centigrade, which is given by E naught is equal minus 0.0591 by N log P2 by 1, because we take the concentration as 1 molar HCl at the pressure P2. I already told you that E cell is equal to E right minus E left. This P2 is at the right half cell, P2 pressure, minus E naught minus 0.0591 by N log P1 by 1. We take this as a common. E naught is a constant value, and we'll take that 0.0591 by N log P1 minus, we are taking this as a reverse. And finally, 0.0591 by 2 log P1 by P2. Since this N is equal to 2. Since E0 for the concentration cell is 0, the EMF of the cell at 25 degrees centigrade will be, the formula is like this. E cell is equal to 0.02955 log P1 by P2. And the process is a spontaneous because the expansion of the hydrogen gas from the pressure P1 at one electrode to the pressure P2 at another electrode. That is, the P2 gas, the pressure of P2 will be less when compared to the pressure at P1. So this is about the electrode concentration cell. Coming to the electrolyte concentration cell. Which I will discuss in the next lecture. Thank you.